So we're going to go through the logarithmic rules section of the logarithms unit. These are going to be very similar to exponential rules because, as you know, logarithms and exponents can be switched back and forth between forms. So there's a product rule for exponents, which says that if you have exponents with the same base, you can add them. That translates into logs pretty similarly. So if you have log of m times n, so two things, that actually turns into log of m, log of m plus log of n. Actually, sorry, that should be log base b of m plus log base b of n, and a b on the front there. So the base stays the same for them. Similarly, for division, you take m and n and you subtract them when they're exponents. Well, it turns into almost the same thing in logarithm. So if you have log base b of m over n, it turns into log base b of m, the top, minus log base b of n, which is the bottom. And the last one is the power to a power. So if you have a power raised to a power, you end up multiplying them. That's kind of similar here, except if you have log base b of m raised to the n power, that actually turns into this n here gets pulled down in front. So it turns into n log base b of m. And now that sounds kind of confusing, but it actually turns out to be super easy. One very important thing, that the bases remain the same. They don't change. So if it's base 5 for everything, it stays base 5 for everything. They don't get split up, they don't get divided, they don't get multiplied, added, nothing. The bases stay the same. These all have base b in them. Every single one doesn't change. The other two basic relationships that are important, which if you really needed to, you can plug them into your calculator, is that if you have a base and a number that are the same, that ends up being 1. Because if you switch the form of this, it ends up being b to the first power equals b, which makes sense. And log base b of 1 is always going to be equal to 0, which if you switch that, it ends up being b to the 0 power equals 1, which again is always true. So let's look through an example here. Express x in terms of p, t, and q if log base b, so I'm going to rewrite this, if log base b of x equals log base b of p plus log base b of t minus minus 1/2 log base b of q. And we want to work from left to right as we're going through this. So we're just going to start. Well, we know that if you have two things that are being added, that ends up being multiplication. So this is going to be log base b of p times t. And then I'm going to bring everything else down. Minus 1/2 log base b of q. Now the next thing you should notice is that this 1/2 here can be pulled up to become an exponent. So you're doing the power rule backwards. So this ends up being log base b of p times t minus log base b of q to the 1/2 power. And then the very last thing that you're going to do here is you're going to take that whole thing and it's being subtracted, so it turns into a fraction. So our final answer would be log base b of pt over q to the 1/2 power. And that there is your final answer. You've written it in terms of pt and q. If you break it down there. So actually the very last thing you would do is you'd say log base b of x equals this. And this is my favorite part of the entire unit. If you have log base b of something equals log base b of something else, you can drop the logs which is Shib's favorite thing to do, and you just end up with x equals pt over q to the 1/2. And I know that goes into the trial thing there. I apologize. So this problem is going to be just a little bit different. We're going to take what they gave us and we write an expression that represents the log of that. So we're going to take x equals m squared n over p square root of s, and we want to take the log of both sides. And I'm not going to put a base because we're just going to assume it's log 10. So log of both sides. So we're going to have log x this whole way down here. And this other side now we need to break up into the different pieces. So we're going to have, the first thing we want to do is take care of this division. And we know that division turns into subtraction. So we're going to have log m squared n minus log p square root of s. Now we want to take care of this piece here and this piece here, which are both multiplication. So multiplication, we know, turns into addition. So we're going to have log of m squared plus log of n minus log of p plus log square root of s. And we should definitely put some parentheses in there so we know that it's all grouped together. The last thing you want to do is go ahead and take care of your exponents here. And this is actually an exponent as well. This would be s to the 1/2 power, right? So the very last thing we want to do is take those exponents and pull them down in front. So we're going to have log of x equals 2 log m plus log n, and that's going to be in parentheses, minus, in parentheses, log p plus 1/2 log s. And that would be your final answer. It looks really complicated, but it's actually broken down as far as you can do it. So what I would like you to do is try number 3 on your own. What I want you to do is find the value of x. So that means you would just use the properties to get things all set up the way they need to be and figure out what exactly x is equal to. This next one we're actually going to do in class because you need a calculator to do it, so we will go through it in class together tomorrow. And this one I would also like you to try solving for x. You're going to use the properties again to get it set up right and figure out what x is equal to. So give those two a try. If you can at least simplify them down using the properties, you'll be able to get down to the step where you drop the logs and then solve for x all on its own. The next thing right here is the change of base. This is probably the second most important thing that you need to know for this unit. The calculator only does log and ln because all other bases can be written in terms of base 10 or base e. So what I mean by that is if we have log base a of m, you can change the base of that. The way you change a base is you take the top part, stays on the top, and the bottom part stays on the bottom. So you can actually write this as a fraction, which is log base 10 of m over log base 10 of a. And you can put that right into your calculator. So in your calculator, it will be log m divided by log a. So whatever number you have for m, whatever number you have for a, will just be what's in the parentheses there. So if you wanted to approximate this, I'd actually like you to do this first thing when you get into class, is plug that into your calculator. So remember, it's going to be a fraction with a log on top and a log on bottom. So give that a try as soon as you get into class. I know there were some distractions in the background. I apologize about that with bells and doors opening and doors closing and all that. But try the couple examples I asked you to, including that last one there. Other than that, have a wonderful evening.